Hey guys, welcome. How's it going? Just getting my microphone on here. Do a quick monitor check. Keep an eye on the chat on my tablet here. How's everybody doing tonight? Yeah, me too. Let's see. I'm gonna maybe give a little more. How's that? Reasonable? Main thing I want to do is just make sure there's a noise filter. There's a lot of ambient sound outside, and air blowing and things. So clear my throat and get ready here. So we're going to be going over, we're going to look at, as you can see I've been debugging tonight. We're going to be looking at the Marlin code base. We're going to take a high level look at how things are arranged, where everything's at, and kind of the work, and maybe get into the flow a bit of how the code actually runs and how tasks are actually accomplished, from stepping the motors to, you name it, there we go, stepping the motors to updating the LCD, reading the G code, checking the sensors, sending stuff to serial, interacting with the host in all kinds of ways. All that stuff we're going to take at least a quick look at and get an idea of how this thing flows. So if you have ever looked at Marlin before, say Marlin 1.0 or Marlin 1.1, they were a flat file system, so we had one folder full of all the source code. All the CPP files and all the H files were all in the same place. So it was kind of a very, it was not as organized as it could be, because we'd have to name files with the prefix to make them group together. And that was just a limitation of Arduino IDE. There was no way to get it to handle that for a long time until I think maybe 1.8.7, or I can't remember what version it was, probably 1.6.8 or something like that. But yeah, they added the ability for us to have hierarchical file systems, and that changed everything, because we could use, we could do all this kind of stuff here that we've got, like all these things are included from various folders, and so you can kind of get a sense of what this file depends upon in terms of what we call modules and other things. But let me get a quick view of the folder structure that I put together for Marlin 2.0 to make it more organized. So to begin with, we have at the very top level, if you can see here, you may have to zoom your screen up, a build root folder. And that contains things like executables or little scripts and extras and fonts and things that come with Marlin that are support files. And that's basically where we're going to put anything that, even though it's called build root, it sounds like everything that you do in there is going to be part of things getting built. It's just a legacy name. It's just sort of like the things that are in here are what we had in Marlin 1.0. So in the final version, this may change a little, but right for now, all the extras like scripts and things and stuff that helps Marlin do its tests and so forth is in build root. We've moved all the config files to a top level folder. So the default configs are always in a default folder. Those will tend to match these config files here, although I'm right now looking at my branch, so they're a little bit different. You can see I've also got boot screen and status screen, and those aren't normally there. Then there are some examples, and there are a lot of examples. They're named by folder. All the folders are named by manufacturer for the most part. And then the models, if there are multiple models, they'll be inside of these. MKS actually is referring to boards. So sometimes it's just a board that might be a generic Cartesian. But for the most part, these are actual brand names. And we tried to get as close as possible to the config that works well with it, and sometimes we get advice from users as to how to tune these. So these may actually be better in some ways than what the manufacturer is distributing. So all your examples are in there, and you basically just take, as you may know, you copy whatever's in here, configuration.h, and you bring it out to the top level and replace what's here, and then use it as your starting point. You might want to change the name of the machine or do other things. So that's how that works. Then we've got a file folder called data, and that's actually part of when on the ESP32 Wi-Fi. That's a folder pertaining to its web interface. And I guess I don't know exactly why it has to be here. We may move it, but it's included for one reason or another. Then we have a folder for docs, and the only thing that's in there currently is just a little description of something called the Bresenham algorithm, which is the clever way we use integers to draw lines and keep them all synchronized in Marlin. It's a fairly common algorithm. It's used originally, I think, in television circuitry, and then later on, and it's used in all kinds of applications now. But it's great for basically doing very fast linear moves. I probably won't even need these, so there you go. Less coverage of the screen. Then we have the Marlin folder itself. So just looking at the top level, here it is, Marlin. And this is got within it closing that. It'll have, by default, it'll have a configuration file, which is your main configuration, your main options. Then it'll have configuration ADV, which has advanced options and add-ons and things like that. Then it'll have, and then you would maybe put your boot screen here if you were going to use a custom boot screen, and you would put status screen here if you were going to make a custom status screen, as I'm showing here. So these are just the folder root, and that's where Marlin expects those to be. There's also a make file, which is customarily above this src file, sometimes inside. So we may move it inside, but right now I think that's all categorized, so we like it this way. And then there's the customary Marlin INO file, which is what you open to make Marlin open up in an Arduino IDE. And this actually right now, because we don't have any code in here, it's just a hook for Arduino IDE. And then from this point forward, like, it just has comments and links and a few things to help you. And then the actual code is going to open up from the source folder. So the main file, because it's named the same as the folder, marlin.cpp, marlin.ino, it automatically finds all these things. So that's the way that works with Arduino IDE. With Platform IO, it works a little differently, but same idea. It basically just builds all the CPP files it finds and includes all the libraries that you've told it to include based on your platform. And yeah, so it's a little different, but the same. So looking at what we have here, the Marlin CPP file used to be in Marlin 1, where all the G codes lived and a lot of support code lived. So this has gradually been completely reduced. All the G codes are moved into individual folders, which are in this G code subfolder here on the left. Then we have, so currently this basically is left to include a lot of stuff, like it's a lot of features that are mentioned. You can see all these includes inside of Marlin are including modules or feature code that is hooked into the stuff in this folder, or in this file. And this file basically contains a bunch of functions that are fairly common and kind of what you would call the Marlin object functions, I guess. And some of these will get moved around, enable all steppers and things. Could be part of stepper, for example, and things like that. They could all definitely be moved. But right now it's gotten down to the point where it went from 15,000 lines originally, and now it's down to like 1,166 lines. So fewer than 1,200, so 10% of its original size. And yet, if you look at it, the main loop is here, and the setup is all done here. So yeah, this is I'll follow through. Basically, the Marlin file contains, by default, this is a standard, again, behavior of Arduino. It has a setup function that gets called, and that's what this is. And it's calling all the setups for all the features and other things, and add-ons and devices. And then there is a loop, which after the setup gets called, and basically the loop is called repeatedly, but instead Marlin does a little optimization and just does an infinite loop inside of loop. So it leaves the stack pointer wherever it is and does this infinite loop and calls things from there, which just makes it have to go it branches instead of having to do this return and then call, return call. So slight optimization, and there are many in Marlin. So that's what's going on in this file. And then it has, of course, its support.h file. And the .h files, if you're not familiar with C++ or C, is files that other files include in order to find out what the code is in all the CPP files. And then also they can include other stuff. So Marlin.h basically includes references or definite declarations of all the functions that other things will need. It also includes declarations of a bunch of macros, and that's what these defines are all about. And it includes basically just the stuff that is like, core stuff for the main loop. Then we get into these other areas. So there are, let's skip over, not alphabetic. Instead of going alphabetically, I'm going to go by what the theme would be. So I think the first thing to look at is going to be ink. Ink was added to contain all the things that you would need to include as a group for just about any source code that Marlin is using, except for maybe a library that it's including. Libraries will include their own stuff, but Marlin needs to include a bunch of things that it can then use throughout the code, things like macros and certain defines, and of course your config options need to be available in all the source code that you're looking at. And so ink was created to contain all that kind of required stuff that is going to be the core of what Marlin can use, and kind of gives its sort of flavor and identity as a code base, really. So to begin with, if you look at looking at Marlin.h, for example, you can see right here it has, and I'll just zoom up a little, it has include ink marlin config.h, and that is right here. And this one includes all these things. So all of these things like our language and our macros and other things, a lot of stuff from core gets included. And so I'll pop that open. You can see here's all the core stuff. And so there's a lot of things there. The idea here is to also impose a certain order, because we want to make sure that you first have everything from Marlin config pre, which is a kind of the quicker include. Like if you don't need all the stuff that's in Marlin config, that's why Marlin config pre exists. So there maybe is a slight speed up because you're not including as much stuff, as many definitions. And it's typically used in headers that might be derived from third-party stuff. Some of the HALs probably include it, even though we're trying to make the HALs fairly agnostic as far as features. So this defines, first off, Marlin firmware, which I don't think we actually look for anywhere, but there it is. So if anything wants to look for it, it can be like, well, I'm being built under Marlin firmware, so there it is. Although other headers, third-party headers, don't necessarily see this header. And that's the nature of headers. They only see each other if they include each other. And it's the same with CPP. They only see the headers they include, and then the headers that those headers also include subsequently. So this Marlin config pre first includes all the main HAL platforms H file, which like sort of bootstraps everything as far as what the hardware is. So at that point, it's basically including a thing that says, okay, what am I being built for? Am I being built for Linux or LPC or whatever? And it'll actually then set certain defines and include the right HAL for the platform that's being built, and then continue from there. So it brings in all the good HAL hardware stuff. We then have boards.h, which defines the board defines. Only one of those ever ends up getting used because you're basically, throughout the code it does things like, is this motherboard, and so it needs to know these boards to be able to ask that question. Then there's macros.h, which defines, and if you look into it, I'll pop it open, it defines lots of macros. Here they are. And these macros are all used throughout the code for things like checking to see if an option has been enabled in the config. So there's actually an enabled macro. There are some math helper macros, things for building, basically All the macros that you would tend to use in just about any code they're fairly generic. Some of them are a little weird. They go in these like, array 1, 2, 3, 4, 5, 6. This is all just macro voodoo, because in order to get a certain number of items into an array, you have to first figure out how many pass that number, and then make synthesize a name, and yeah, it's weird stuff. So macros can be weird. We also make all the math functions into macros, all these generic math functions, because the different platforms may work differently. Some use doubles, some use float, and in some cases the doubles are optimized and the floats aren't, or one uses software, another one uses an FPU, and so on. So we've got these defined to basically ensure that they'll be using float, I guess, in this case, and they may be redefined when in platforms where they're needed to be other things. So yeah, macros is included, and again, this thing which defines it for millisecond stuff, for some version defines, and then this is where the config stuff really comes in, is version H, configuration H, conditionals, core drivers, the configuration ADV, conditionals ADV, so all this stuff. So basically, these are all being included. And what happens is at first you get your configuration, then we check that for like, okay, well, let's see, based on this configuration, we should set some conditionals that basically are reactions to those. And those are set early, and that includes things like what is the LCD type, and then some sub options. Then we look at like, and that's why then later we have configuration ADV can use stuff that is mentioned there. And then there's conditionals ADV, which then expects all the configuration stuff to be pretty well settled business by the time you get there, and then it fills in even more conditionals. So conditionals are, again, they're just like, if this option is defined, then set this other thing which is equal to 5 by default, or check if this option is enabled. And so it does certain kinds of sanity checks sometimes, setting default values. Pins files will also do that for their pins, but they're just there basically to provide accompanying things that you don't necessarily want to override or have in configs, but you still want to have effects throughout the code. So again, core drivers.h, that's another interesting new addition, and I'll just give you a quick preview of that. And that just tells us that we have defines for all the different types of stepper drivers. So A4988, A5984, I mean, there are so many new ones coming out all the time. But most of these are trinamic, and then there's like macros to be able to check, based on what axis you're looking at, does it have stall guard, so on. So yeah, all these kinds of things are included. Marlin config then goes on to deal with, to get the HAL and really bring in the HAL itself. Then there's the pins, of course, they have to come in. Yeah, so pins are like the last thing. That means that in the configs, you can always override a pin, because they're set later. Sometimes pins don't check to see if a pin is set, and you might come up and say, oh, this pin is already defined or whatever. But that's easy to work around. You just put an if-def around it. And you can see those in other pins files for things like the filament sensor and stuff. And then there's the SPI, which is apparently a very special type of interface, because we actually have to include it after pins, but not as part of the HAL. So conceivably, we could move this up into the HAL and this up into the HAL and kind of have these all be hidden. But it's kind of nice to have this laid out so that we can see the order somewhat imposed. And this is fairly low-level stuff. This is all, defining the interfaces to the actual hardware. At such a low level that it's just basically, how do you turn them on and off? How do you read them? Really basic. Then the conditionals post stuff is the big final conditionals file that just deals with all the possible arrangements of options. And the last thing before we get into things that are going to be kind of generic are sanitycheck.h. And that basically actually checks through all the options and makes sure that they're sane. It looks for old names and tells you if you need to update them. And basically this has been something that's been built on over time. Like every time some new option comes in or something changes, we try to be very diligent about making a sanity check, so you'll know what to change or fix or whatever. So yeah, so all this stuff then enumerate enums, which are, again, they're just more names of numbers basically. names for numbers, then the language stuff, which based on which language you've defined will bring in your Chinese or your English or your Dutch, and then serial, utility, and min-max. So again, more things from core, and that's all these files. So core, again, was basically built to house all the types of headers that hold very basic low-level stuff, including the serial and utility file, which are basically used everywhere. So core is stuff that you're going to always need, pretty much. And then, is there anything else in Ink that's of interest? The sanity check, of course, lots of, if you look at this, it's just got lots of error messages, and they're just endless. You can see here on the right just how many there are here. It's just so many. It is crazy. But it makes sense that we make sure options are sensible. If you do some of these things that it tries to prevent, it can hurt your machine or break your hardware. So this is actually a part of the security of making sure that Marlin is reliable and safe. Believe it or not. Yeah, because code can be dangerous if it's not written right. So yeah, if you're familiar with the configs, I'm not going to be going through those at any level right now, but yeah, we have, if enabled, and it just checks options. Like all the options are these uppercase things with underscores, and you'll just see throughout the code, it's just a huge maze of if this thing is enabled and if that's not enabled. And yeah, I guess I maybe should go through a little bit of that detail here in this intro, since I'm going over the code base and how it works. If you've done configurations before, you can just skip on, and maybe I'll have a timestamp over here or something for you. But the basics are you set a define. It can just have a name and no value. It can have a value. It can have a value that's a string or a whatever, because these are just basically replaced literally by the text you put next to it. So but we can also look at these values and say things like if enabled and so on. And so these configuration options are used everywhere throughout the code to determine what's going to get compiled in and how it's going to be compiled in. And maybe, certain things will be compiled in with different values passed to them and so on. I mean, these pretty much control everything that gets built. It's a little different from something like SmoothieWare or probably RepRap firmware, where everything is built that could possibly be there, and it's in a sort of a more generalized way, and maybe there's a kinematic that's there and it's not in use. When you're using Cartesian, the delta code might actually just be there. So, for Marlin, since it's meant to be built on a very, very small board and use up minimal space, it tends to use all these defines as a way to determine what's going to be actually built. And then that makes it all smaller. So you'll enable something like mixing extruder, and then because it's enabled, now these will be also enabled, and then you can change their values. And so that's the way it works. And then somewhere in the code there'll be something like, if this thing is enabled, and we'll just pretend I was playing with advanced pause feature, then this parameter will now be part of idle. Like now you can tell it not to sleep the steppers, and it's normally false. Like weird things happen because of these features. Sometimes it makes the code a bit hard to fathom. Macros are not always the clearest. But one of the aims was to sort of reduce repetition, which meant like if some piece of code is just going to be a cookie cutter of the thing that came before, and there's going to be 10 of them, we prefer to make a macro and then have the macro just have 3 things and define it once and then repeat it those 4 times. And so sometimes that makes things a little opaque, but the idea was to make it flexible and to make the code be very self-similar, even if you're switching sometimes kinematics and drastic things. But here and there, we've switched off to things like templates, which are another feature of C++ that let you be more generalized, and so on. So yeah, if you're familiar with the configuration, you've done it before, you know all about this kind of stuff. But under the hood, that's pretty much what's going on. It's being checked and it's changing what's getting compiled, morphing it, as it were, into the Marlin that you want, and so on. So let's see, we've looked at core. and that with its macros and some other helpers, debug, serial, and so on. We've looked at inc, which is our core includes, and which just about everything includes, and also reduces, it simplifies things. All the things that are included in the inc Marlin config pre and config files are things that other files don't need to directly include, although some of them may, serial.h or whatever, just to kind of give a hint as you're reading the code that that's in there. But you don't necessarily have to. That's the nice thing about this, and it also imposes the right order again. So at this point, I want to just check in the chat and see if anyone has any questions about what I've discussed so far. Obviously, I'm kind of rushing through, but I know that these things can go on for hours. So I want to get the overview, and then we can get into more details if you have questions about what you've seen so far. So just popping through the chat, we have, let's take a look. I wish I had my reading glasses. Let's see. We'll work our way backwards. How's Marlin 2.0 on ESP32 going? Really well, better all the time. It and the STM32 are both getting a lot of attention. I think actually there's also, it has the web interface is also there, so you can actually use the web interface on the ESP32, and it works. So I would recommend checking it out. Please raise the volume. Yeah, is it really low? I will. The one thing I didn't want to do was have it sound too much like a room. This is the most that I can actually turn up the gain, but I could add a filter that would gain it some more, and I could maybe tweak the noise suppression a little bit. But thanks for asking. I'll do a tweak on the gain. We'll go with 0.9 dB. Is that going to be too much? All right, we'll see if that works. Okay, didn't even see your post. Yeah, well, welcome, Jake from State Farm. Don't worry, it'll be online for all to see. I'm glad you could take part live, though. Thanks for joining. Hey, Matt. Hey, dude. Brian's here. Brian Vines, BV3D, who has provided the kind donation of the laptop that I'm now using to stream this. Thank you, Brian. I just sent off the broken one, or I'm sending it off tomorrow. I filled out the form to Rossman. Louis Rossman. He's on vacation, so someone else will end up fixing it, but that's okay. I should have stuck a big BV3D sticker on it. Yeah, so let's see. If anyone has any other questions, please post them now. I'm just working my way backwards, and I see. Oh, here is one. Hey, is there a technical reason why U8glib are excluded in the STM32 environment? I am not aware. My guess is that it's just not compatible. We're using an old version, 1.0, I guess you'd call it, and there's a 2.0 out. But we haven't used it because it is a bit fatter and a little more, sometimes not as quick. So but I mean, it performs really well. Like, it's actually optimized for things like drawing lines and all the kinds of things that you would want to do graphically. But it actually doesn't add a lot for the simple things we do of drawing boxes and icons and stuff. So we've stuck with one. But if we find, if you do find that STM32 is, or any other HAL is having trouble with UHG, we have UHglib-HAL at our own copy of it inside the Marlin firmware project, so we're actually able to update it and make tweaks, and they'll go out, they'll roll out, and it'll be built the next time you bring in that version of the library. But it's a good idea, I think, in general, to just make sure you have the latest version of UHglib-HAL. Platform.io will get it for you automatically, and as far as actually building for AVR, it probably doesn't matter. You can just use whatever UHglib you have, and it'll be fine. The HAL version is mainly to be able to support the other 32-bit platforms and make them work well. So, next question. Big fan of the pre-written configs, says Bakar. Thank you, Bakar. I agree. I think they really help, and especially the fact that, yeah, as I mentioned, they're sometimes optimized and improved by users, so they're actually better than what you get from the manufacturer. Uh, Freddie is here. Insanity Automation in disguise. David, good to see you. And who else is here? Hey. And yes, thanks for the info. Okay, well, let's carry on. Take a look at the next part and see what's going on with it. So we've looked at HAL. Okay, we haven't looked at HAL yet. Well, HAL is another folder I'm not going to get deeply into, but I want to show you it has all the platforms. And this was a kind of a gamble. We didn't know going in if this was really going to work, but I had my fingers crossed because I knew already HAL do existed, so to speak. We already had Marlin running on do, and it was basically an adaptation. There were a few hooks added, or what you might call glue code, to make it so that you can just simply use the same interfaces that we already had, the same code, and just it'll work on this new platform, and very minimal changes needed. So building for do was actually very easy, although we've added a lot. You can see here inside of the folder we have had to add a lot more to deal with nitty-gritty details. SPI is one of those things that it seems for almost every board we have some kind of specialized SPI needs, and that's often just a case of the fact that Marlin itself has kind of wanting again with its fast I/O stuff to be really optimized. And I mentioned fast I/O. I'll mention that more. But essentially, that is our way of going directly to pins and their ports, rather than going through the Arduino libraries, which is slower. So we get much, much faster performance through fast I/O. And that also matters for 32-bit. We're using fast I/O even for 32-bit for most cases, although a lot of them do actually just use digital write and digital read as their pass-throughs. So it's kind of doesn't almost, I guess with 32-bit, the theory is it doesn't matter because they're so damn fast. So, in some sense, I agree. If the code that leads up to, like just calling digital write itself is smaller, and the code that runs in the background might be a little slower, you still get smaller code, and that can sometimes help performance because less reading of code is actually part of the equation. So yeah, we have so what was originally Marlin, just Marlin 1, was HAL AVR, and so all the stuff that's in HAL AVR kind of defines the stuff that would need to be in other HALs. And I like this approach. It really worked. There weren't too many approaches you could take while keeping the same, pin direct level of performance. So using this kind of, rather than an emulation or some kind of virtual machine or something like that, we just made, bit by bit started to cobble together the interfaces. And there's been just an amazing amount of great contributions to help, especially with some of the trickier things, and SPI being one of them. With each one you have hardware SPI, software SPI, and each HAL determines, things like the end stop interrupts will be different for each one. They'll all have different fast I/O needs. They all have different serial needs. They will all have different pins debugging for the most part. Sanity checks may be different or special. There's also servos are also different oftentimes in their timers. SPI again, constantly interesting. And the watchdog, of course, is a special timer that each processor has, and so that's and some, I believe they all have them for the most part. So that's there for safety again. And yeah, so all of these things will generally need to be defined. HAL AVR sets the tone, and then do really sets the tone on, like, the add-ons and variants that you might need. There's an ESP32. Here it is. As mentioned, it's there. It's fairly complete. There is that WebSocket. You can see it all there. There's a HAL for Linux, so you can actually build Marlin and run it on a Linux box and in a simulated type of environment. But if you want, you can then set it up with real pins and actually have a Linux machine run Marlin and derive something. So that could lead to some interesting things with, in terms of the way the clipper works. It does everything on the Linux side except for the last part. well, this would do everything on the Linux side except for nothing. So it's kind of an interesting option. The LPC 1768, of course, super popular. Smoothie board, the MKS S base, the rearm, there is so many. There are just so many, and they're really, it's a great chip. It makes for great boards, and just very complex in terms. I mean, it's popular. It's so popular. You know, we need extra UHG stuff. We need, because actually it's more LCDs have actually been tested probably with this variant than any other, except maybe Do. Although Do is, I don't know, it may be limited. I know that people like their panel Do, and I know the Nextion has been partially brought over, maybe fully, but not in Marlin. It's only very barely started. So anyhow, yeah, we got LPC 1768. Then we have STM32 is interesting. There, eventually, I assume we may have just one STM32 folder. This is what you call STM32 generic. And you can see it's actually, there's not a whole lot here. It's pretty amazing how little there needs to be. But then you have a specialized one for the F1, F4, and F7, which are all slightly different from each other. And so each of these is based on, I want to say, I should put these things in comments, but I think it's built on something, a different variant. So in any case, I don't know the language to use, that's all. I know that they're different. But yeah, these are different cores, essentially. This is the generic core, and these others are STM32 specialized cores. So they can all, you can build for different boards based on just STM32. You could build maybe for all the boards with that one. But if you had an F7, you would maybe choose to use this instead and get perhaps better performance or different kind of features and options in terms of timers and things like that. It all depends on the core and how it's built. They all have something like an Arduino type interface for the most part. And so we're able to just include something out there called Arduino and get most of the functions and things we need. But there have been cases where things are weirdly different, and you have to actually adapt to that. Most of the time, though, they are very much the same. We then have Teensy, so there's a Teensy 3132, the original Teensy boards, and then or Teensy 3s, and then the newer, fancier, cooler, many more layered Teensy 3536 boards, which are super performant. The thing is, I don't know that there's a lot of machines built around them, but you know, Printerbot is one example that used the Teensy 31 or 32, 3.2, and so machines have been built around them. They have enough general I/O, general purpose I/O to be able to do that stuff. And then within there, you also have now a shared folder, and that's all the stuff that is going to be very similar. So servos, and at least the interface for servos is going to be here, and then the generic interface. If there's a servo inside of one of the others, like here maybe, maybe not here. Oh yeah, here, HAL servo STM32. So just to be clear, it's in the HAL servo STM32, and so this would maybe add on more, or yeah, build on servo as something called libservo. So yeah, and so they build around stuff, and then this also has some math for 32-bit, very general, a generic Marlin serial header that the other things implement. There's a backtrace, which is for doing debugging at a low level. Yeah, all this kind of stuff is here. There's specialized EEPROM. Sometimes the EEPROM isn't really an EEPROM. Sometimes it's just writing to a file on your SD card on the board, or sometimes it's using the flash. So those options are all available through the HALs, and each one will be different. And sometimes the pins files also make some adjustment there. So again, HAL, now pins, I guess, comes next, because this is where, for any given board, you're going to have all the pins defined. And there are many pins files now, and they continue to expand. Some of them are, some of them are very similar. And so what happens is we'll say inside of the file, it'll just include the other pins file and then make adjustments. Sometimes it'll do things before they include, and then the pins file it's including knows to look for that those things or that those things might be overridden. You might follow that approach more because it's nice to be able to have pins files assume or be able to have pins overridden. So pins ramps is like, for example, one of the more, certainly the core and most popular pins file. It's used by a lot of other pins files include it, and then make minor adjustments or sometimes major adjustments to it. But it defines, we'll just go quickly through the anatomy of a pins file. There'll be some comment at the top about what it's for and what it's about. We do a little check to see if you're actually building for a platform that supports this pins file. So actually, the ramps file, if you're using an LPC 1768, with certain boards, you may have a ramps like add-on, and apparently they use ramps type pins, and so you can even be building for STM32F1, and yet the pin numbers will be included from ramps. If the board name isn't overridden, what we do is we define a board name, ramps 1.4 being the default. Then we have servos, and then the pins for those will be defined. In the case of ramps, pins are just integers, so they're numbered, and the numbering scheme we use is kind of a complicated story, but essentially we try to use the digital I/O pin as defined. The digital I/O pin number that would be, say, in our Arduino sample code, and that's how we define the pin numbers. And with other platforms, we have to do them sometimes by port and then sub-pin. So it'll be like port B, pin 3, or something like that, which doesn't mean the port on the board. When you're looking at the board, it'll say like aux 3 or something. It actually means the chip itself has, the pins are defined in terms of little groupings, and each grouping is called a port, and that port has maybe 8 pins on it, which maybe correspond to bits on that port. And so that's kind of how ports and pins work. And so you could look at these ramps pins, which are numbered as integers, as being also port pin combinations, but you just don't do it that way historically. This is the way we've done it. And it does make things a bit simpler because these pin numbers are used in some macros to join up names and find whether they've got PWM or other things, and those tricks won't work if the pins aren't numbered in an expected way. So it's a bit of work to change a numbering scheme, but that's the one we've settled on for this. And for most of the AVR boards, well, I'd say all the AVR based boards, that's what it is. And then for some of the others, as you get into like rearm and others, the pin numbers become, as you see here, pin 202. So these pin ports aren't even lettered, they're numbered. You might have PA02 or something like that on a typical AVR board, but that's the way they've done it here. And then these other numbers here probably correspond to ramps pins. So you may be able to even find some kind of family resemblance between these. In any case, back to ramps and the pins, next thing comes limit switches, so your end stops. Here we only are saying, well, the X max pin is probably going to be overridden. We probably ought to just do it with all of them because then you can override them. But for the most part, they're labeled on the board, and so you're expecting the label and the name to kind of match. So that's why we're keeping them this way. They're also X stop pin. So if your board only has 3 end stops, you can just use like X stop pin. And depending on whether you've set min or max as your direction, it'll choose the proper, it'll do the right thing, basically. So you don't even need to necessarily use min max here in the pins file. So here we have your min probes. That's your probe. No matter what kind of probe you have, it's going to have some kind of pin that probably gets triggered, and that's this pin. By default, if you're using probes most of the time, your Z min pin will be the pin that is the probe pin. This is meant as an alternative to that pin. So then you have steppers. So you have, with every stepper, you have enable, the stepper is turned on and powered and getting warm. You have direction, so when we do a step, which way is it going to go, left or right? And a step pin, which when we trigger it, either go high or switch to low, or do a high then low. And depending on how your stepper driver is implemented, you may just be, if it changes from low to high or high to low, it's a step. Usually it's in one direction. You change to high, it does a step, you change back to low, nothing happens, but it's ready to go for the next one. And then there's a delay sometimes with the step pin, like it's on while you do the step, and then when you turn it back off low, you want to wait a certain number of milliseconds because that's expected. So that's the way those pins generally work, and you have to set them for all your steppers. And then there's also a chip select pin for SPI if your stepper happens to be SPI controllable. And generic ramps boards don't have that, but we do set pins by default that are available that you could use. So these are there as options, but they're overrideable. So that's what that's about, if NDEF. If this is not defined, we can override it. So then you have your extruders, and then same idea. Then you have your temperature sensors. These are analog pin numbers. So these will actually be between 0 and usually between 0 and 15, depending on how many analog pins you have. And an analog pin, if you don't know, is a pin which returns a voltage or a resistance value as a proportion usually between something like 0 and 255. And so an analog input will look at the resistance, and if it's 100% resistance, completely resistant, it'll be one value, and at the other end where there's no resistance, it'll be the other extreme. And at 50%, it'll be 128. And so these pins are numbered that way, and so they don't actually correspond to digital pin numbers at all. There may be digital pin numbers that correspond to them when you're doing digital I/O with those pins, but you'd use different numbers when you're talking about digital pins as digital pins than when you're talking about them as analog pins. So a little background. So that's what these are. These are your heater 0 for extruder 0, heater 1, and your bed pin. And then we check to see if SD support is enabled, and these are the same, so I don't know why this is here exactly. So either way, it's going to set this max, but that's for a thermocouple, so that's why it's in this section. Max 6675 thermocouple, so there's a pin for that, which is essentially the chip select pin. Augmentation for auto-assigning ramps plugs. Yeah, so here is something that just ramps does and other things don't, but it just checks to see whether you're using more than one hot end and so forth to decide what your MOSFET outputs are going to be used for. So it assumes it's going to be extruder, extruder bed, or extruder, extruder fan, or extruder fan bed, or extruder fan fan, and that's figured out here. And essentially this is historical stuff. We didn't want to make every single pins file have to make this decision automatically, but it's not a bad idea in a way. It just sort of imposes an order, but it's you can be more flexible and do it and override these by setting your own MOSFET pin numbers and rearranging which pin numbers are which. So these are passed into the ramps file by other pins files often, and it's just basically what are these MOSFET outputs, and there's typically 4. So I just numbered them D8, D9, D10, which is what they normally are on a board, and then something called D, which is your extra MOSFET, which some have. You can also use MOSFETs for fans and things and they're typically 12 volts, so that's why you have a MOSFET, because or even 24 or more, to pump the voltage through. So heater 0 pin, so there again, these are the actual heaters. So these are going to be turning these transistor MOSFETs on and off, and at a rapid pace or a not so rapid pace, but sending voltage through to heat up your bed, or to heat up your hot end, or to run your fan. And so all this stuff is handled here, deciding what those are going to be. Then we have your SDSS, which is for, again, when you're using SPI to talk to your SD card, what pin needs to be set to make that happen. LED pin. Filament width sensor, another analog input. Here we know it's on auxiliary 2. We could even label it if we knew it was on 3 or something, but I don't know which one it is. So anywho, then you have what's your filament runout sensor pin. So we sort of provide a default. If you haven't set it, we're going to assume you mean pin 4, which is a digital pin that just triggers when you've run out of filament. Power supply on, you can turn your power supply on and off. The default is going to be 12. And then some other stuff, case light, spindle, trinamics. So we've gotten a lot of details about trinamics, and we picked default pins for those. So as you're seeing, the trend here and what is the theory of pins files is that they're going to hold the default pins for the functions that you would want. And if you want to override them, then most of the time we'll put little if and defs around them, especially for the things that are very commonly overridden. And for things that aren't commonly overridden, we don't worry too much. But these are here so you can override them. And so here we have our mux, which is the multiplexer. It uses 3 pins to make a number between 0 and 7. So theoretically, a Prusa multiplexer could theoretically have 8 inputs and select from 0 to 7. So in case you didn't know, you could build one, maybe. It's just 3 pins. LCDs. Then here we deal with all the LCDs, and my goodness, this has been a really fun section to maintain and make sure that, you know, one of the things I wanted to do here is to sort of get a sense of where the family resemblances are. So if RipRap discount smart controller actually means not just the one RipRap discount smart controller, but all these others which are in the family. So in this case, it's the CR10 stock display and the BQ LCD smart controller. And they just have variations from each other. But they share the same beeper pin. And so I try to do that throughout where a pin is the same between something and something else, if it's possible to make it neat and not too ugly, then yeah, show that family resemblance. And try and look for those too. Like if you find a pins file that's got all the, you know, the same as ramps, it's like, well, let's just call it a child of ramps or a cousin of ramps and include ramps and make those changes. So yeah, there's a lot of them. There's graphical and character LCDs. We don't deal with here actually the things like touchscreens. That stuff is all handled through serial communications. So there's actually whatever your built-in serial pins are typically. And you notice that here we're mentioning things like serial pins, software serial to talk to devices. Those are little UARTs that each device may have. But for the most part, all the serial stuff that happens in Marlin is done through known and predefined serial ports on the processor itself, at least by default, like the USB port. And on ramps, it's pin D0 and D1, I think, are the main receive and transfer pins. So yeah, pins, oh my God. So yeah, to look at maybe a difference between that and a 32-bit pin file. So here's an STM32, and here it's saying if you're not using this platform, STM32 F4 or whatever, then hey, it's going to throw an error when you try to build it. And this is using a very beautifully named STM32 F407VET6. And then it defines things like how big is the EEPROM, what kind of EEPROM is it, and there may be some hidden flags in pins files occasionally. And even here, a lot of things that are commented out. I think this is mainly because it's a work in progress. But you see it's very much the same. And here it uses pins that are numbered like this, PE7, PA10, PA8. So again, another pin scheme. But each one, they're unique, and when you look at documentation, that was the idea, to have the documentation and the pins match up in some way, so you could actually read these and be able to just go, oh, the documentation says I should use this, and then just type it in. So that's how these are organized. But yeah, the pins files are included, again, when you've chosen your motherboard. There's a special folder for SD card code. So the card reader stuff, this basically was all, again, in the root folder. And there was, all the SD base file and things is a library external to Marlin that was brought in and then customized. So all of it is here. And then card reader builds around that. And then there have been additional changes and optimizations built around it since then. And there's even now support for using a USB flash drive, if you didn't know. And that's what this folder handles. So it's sort of a subset of SD because it emulates being an SD card, but it's actually writing to a flash drive. So pretty cool stuff. So yeah, all this SD stuff you can pretty much ignore because it's low level, and it's, as we change it, it's pretty much only to support new hardware and new paradigms. We're getting to the interesting stuff now. Libs, I quickly go over. Libs is for code that is like, implementing something like a stopwatch where it's just data, maybe not interacting with hardware, and you just want to be able to maintain a counter for some time, or nozzle, where it's talking about it's a collection of movements and stuff that pertains to cleaning the nozzle, and parking the nozzle is another thing. But these are like, very basic files that are just here. And Bresenham.hx I don't think is even used, but it's here to just illustrate how you would do that Bresenham thing discussed earlier, which is done in a more kind of opaque way. If you look at the stepper code, it's doing the same thing, but it's harder to tell. And then there's also this, that's a special stepper, the L62470, and we've got an add-on here. So this is what you call the glue code between Marlin and an external library that makes it work. And sometimes external libraries will ask you to implement things, and so that's why this is here. This is Marlin's contribution to L62470 to make those stepper drivers work. You have also in here things like point, which is just a data structure to hold XYZ, and that's it. Very little basic things sometimes here. Could even be in core, something like that, but we don't use it all that often, and it's part of movement. So the next thing to look at is module. So module is a folder where we decided that things that are a little more integral or high level would live here. So, but wouldn't necessarily be on and available all the time. So things like a tool change, which you only need when you have more than one tool, is here. Temperature, of course, kind of as a core thing, but and maybe temperature will get its own top level folder at some point. But this is here because temperature is like, it's got a lot going on, and it also has the a service routine, an interrupt service routine, which runs at close to 1 kilohertz. So it's a module. Stepper indirection, stepper, probe, planner, all these things are in here. And this is the stuff, when I get really in depth with the code, I'm going to mainly be looking at module at first, and feature probably will come after that, and some of G code. And I'll get into some of that, but yeah, so these are things, again, this is utility code that's going to be used for these pieces of hardware. End stops, which are, could be feature, but you almost always have real end stops or some kind of virtual end stops. Delta is a kinematic. Motion is, fundamental motion stuff. Planner, fundamental planner block, preparation, acceleration, jerk handling, all that stuff is done there. We have planar Bezier for doing Bezier curves. If you didn't know, we have Bezier curves, G5. There's a print counter for keeping track of how many prints you've done, how much filament you've used, and all that sort of thing. And there's even a maintenance schedule you can set, which will remind you that you've done this much and you should deal with that. Probe, which is your probe, all your Z-probe stuff is there. SCARA to handle SCARA kinematics. Again, there could be a top-level kinematics folder, and we could stick Delta and SCARA in there, but they're not it doesn't mess things up too badly to have them here. Servo, we don't all use servos, but all our boards have support for them, and we can use them if we want, and they come in handy for a lot of things. Speed lookup table is there for basically optimizing AVR motion, and so it's sort of fun part of motion.a. It kind of goes with the motion stuff. Stepper indirection is very interesting. If you ever look at it, I'm not going to torture you with it now. Well, okay, I will a little. Well, let's just look at this here. You can see that it's like patterned. It's like, ooh, lots and lots of things that look similar, blocks and blocks and blocks. What is going on here? Well, it's defining basically how steppers are going to behave when they're given commands to step. And so if you're doing things like duplicate motion, it handles things like making sure that those two steppers move in synchrony. So there are all kinds of interesting things going on in stepper indirection based on the type of steppers, and especially with extruders, like mixing extruder and stuff like that. This basically makes sure that the steppers behave like they should for the type of machine you have, and for all the add-ons and extra, especially the extruder that you have. It's really cool and worth a look, but it's more the low level, like how do I step, how do I set direction, all that sort of stuff is there. And then stepper CPP, which also contains a service routine which runs as fast as the steps that are stepping. So if you can imagine, There's some block of code that every time your machine is doing a single tiny step is running it again and again and again. And maybe it does a loop of 4 within it, but essentially that thing's getting called like repeatedly and really fast. So you can imagine, even on an AVR board, which is not that fast, 16 megahertz, you know, twice as fast as an early Amiga or something, is like not that fast. It is pretty impressive that it can do as much as it can in this stepper routine, which again is very optimized. But that's what stepper contains, is the main core stepper routines. And then continuing down, temperature I mentioned contains that 1 kilohertz thing for checking heaters, for doing PWM, and things like that. Those are all handled in temperature. And that includes things like your the PWM setup for your fans and things is also done in temperature. Tool change, yeah, again, if you have more than one tool, it'll handle switching your tools, which may be very different depending on your tool changing. But for now, it's all extruders. It's all about extruders. We don't currently have the concept of a laser mode with like M450, I think would be the code for that, S2 or something. But we are definitely looking at having modes and then being able to say, I'm using laser, therefore turn off the extruder, and now we're behaving a little differently. So that kind of stuff would end up in module. There'd be like a laser.cpp or something. So that's what module contains. Feature is going to contain the add-on features. So this keeps growing, and sometimes they need a folder. Bed leveling has 3 different types and variants on those, so it gets folders and subfolders. ABL, automatic bed leveling, MBL for your manual bed leveling, UBL for your universal or kitchen sink bed leveling. And then we have a top level bed level, which deals with which of these to include and stuff like that, and then has generic code in it. So bed level is there. Your digital analog conversion stuff is there for things that need that. Digital potentiometers for setting your current on your steppers and stuff, if you have those. LED support is here, so if your BlinkM LEDs or your RGB or your NeoPixels, your PCA 9632s, your temperature, and then things like handling temperature status, changing from blue to red, that's all handled here. And then other printer events like print is done and things like that in the printer event LEDs files is handled here. Then we have Prusa MMU2 is here. So we actually have support for the multi-material unit too, so you can put it on your CR10 or your ANET A8 or whatever you feel like using it with, but hopefully Prusa will sell a few more of those MMU units for third-party printers through the help of this. Then we have baby stepping that actually merits its own feature because it's so much going on really with it, menu items and other things. One of the things that I will mention here is that even though feature contains the code that features would use, when you enable a feature, there's code scattered around like in all kinds of places. It gets in the menu files, in the Ultra LCD files, into the G-code files, into each other's files, because one feature may influence how another feature behaves, and they may talk to each other. So as far as the organization goes, like it's not strictly encapsulated. We do try to create a lot of barriers for things not to like interfere with each other, and we also try to create openings for things that do need to work with each other. There's something called a Barracuda, which is like a paste extruder. There's a BL Touch, of course. I think that's some kind of probe or something. Case light. If you have a case light, we actually have a feature for that. Turn it on and off and set its brightness. Closed loop. There is some closed loop support, believe it or not, in Marlin. It's I haven't played with it, but it's worth checking out if you're a real tinkerer. For controller fan, your controller fan, yeah, your board's fan can be controlled, and it actually merits a feature. I believe it's basically, it turns on typically when your steppers turn on, or your heater turns on, so especially your bed heater, to keep your everything cool, your MOSFETs extra cool and so forth. Your emergency parser, that's an interesting feature. That is set up so that it'll like look into the serial stream as bytes are coming in to see if there's certain commands that are there, and it'll intercept those no matter what. So M108 is an example of that. even if everything else is completely blocked, there's a command running and it's running in a loop, for loop or whatever, and it's doing nothing. This, as long as it gets to the code that reads the serial port, which it does, we make sure it does, it'll get the bytes and it'll see, oh, someone sent M108, therefore whatever I'm in this wait loop for, I'll break out of. So it's a way of breaking out of a loop and things like that. So it's really vital, in fact, I think. It's sort of like also a way of working around if like the button on your LCD controller doesn't work. You could just send M108 and it'll, not necessarily click the button like going into the menus, but it will get you out of something that's like waiting or whatever. So that's one handy thing. So emergency parser, there's other commands there that it helps too. We'll look, I'll bring up the code as I mention each thing. Look at it, isn't it cute? So these are some of the commands: M108, M112, M410, M876 with an S and an N. Like, these matter. And yeah, host prompt support. I should mention that feature a little bit since it's there. Is the ability to tell your host software, hey, put up a dialog that says, do you want to continue? Yes, no. And you can click it in your host software, and then the host software comes back and says, hey, they clicked yes. And so we have that now. But emergency parser makes that possible as well. It's kind of really helpful for that. Fan mux, again, multiplexing of a fan. I've never used this, but apparently it's a thing. Filament width sensor, which adjusts your flow if it sees that the filament is changing width. Firmware retraction, of course, is a G10, G11. We have host actions. So this is, again, same idea. Ask the host prompt is a subset of that, but you can also have the host pause, like say, hey, host pause. And so, yeah, host actions like that. These are fairly new, and we've been working semi-closely with Repetier and with Octoprint to get those implemented. So thank you to those guys. I2C position encoder. I've never used, again, but yes, there's actually a position encoder similar to your closed loop that uses I2C, and I think it can correct the position if it sees that it's way off. I've never used it, so don't quote me on that. MAX7219 debug LEDs. Maybe I'll just change this to MAX7219. But the idea here is you have, well, I have a unit right here I can show you. You've seen these before, maybe, but this wire's stuck. Big old thing. There we are. Yeah, these things. You've seen these, right? MAX7219. Probably looks terrible with my green screen filter, but yeah, there they are. I've got a couple chained together, and yeah, you just you can tell them to set individual LEDs, set a row, and they're really good for getting sort of low-level information out of the stepper ISR that you wouldn't be able to get otherwise. Like you couldn't send it out to serial because you're in the middle of this interrupt routine. It's one of the verboten rules of coding, and well, not coding, but the way that these APIs work is you can't do certain things or interrupt context. The shine on my head's got a black spot in the middle of it. I have to do something about that. Powder it a little bit. All right, let's see what else is going on here. Okay, mixing. Yeah, we have a mixing extruder option, which is derived from, originally I implemented it without knowing anything about mixing extruders except that they were there. And you move 3 motors in proportion or whatever to get the mix, and that was how you get a mix out. So I implemented it really basically, and over time it's gotten more and more fixes because it was not there, and more improvements. And then the A10M, G-Tech sent one, so I was able to actually finally get some testing, and they had their own extra stuff for mixing, like actual like gradients and stuff, so, and some menu items. So I helped them fix those up, and then we brought them over to main Marlin, and now we have it here as mixing.cpp. So you can do some interesting gradient stuff, more interesting mixing things, and again, some of that feature is in the menus, so if you look for it, it's scattered around. Pause.cpp handles not only pause, but also filament change. And resume, because you have to do that after you pause. Power.cpp is for your power supply and things like auto power when needed. So you could conceivably have your power supply is off, your board is awake though because it has 5 volts, and it says, oh, I need to power the motors now, and auto power would be like, oh, okay, well, I see you're turning the motor on, I'll just turn the power on for you and then wait. And so it does that. Pause, power loss recovery. Yeah, that was fun. That was brought over from, again, Creality 3D, and they had a subcontractor do it. Okay, it's a weird feature because it writes to the SD card continuously, and I was whining about that for a long time because it seemed terrible. People have generally found it not to kill their SD cards, but your mileage may vary. It depends on the quality and the rewrites that your SD card can do. Try to only write to it once per layer if possible. But if you have a power loss detection circuit that can just trigger a digital pin, you can set that and then no problem. It'll work just like you expect power loss recovery to work. So it saves the data off to SD currently. And there's some reason for that. It's harder to just save it off to EEPROM, but you could imagine like having a power loss where it saves to EEPROM instead, so that may get extended later. For now, it's SD, and it works. Finally, runout is your filament runout sensor, handling that, and that's pretty neat. It's got a whole class structure with runout sensor. The type, it might be looking for motion, it might be just looking for the presence of something, and so all that stuff is handled here in runout. Single nozzle multi-material. That's actually, again, that's a Prusa thing, which that's just the label they gave it in their firmware, but that's the original multi-material unit, is actually called the SNMM, single nozzle multi-material. And support for it is here. Solenoid, I guess the select multiplex stepper. And yeah, the feature name is MK2 multiplexer, is that. Solenoid for handling a solenoid, so very quick magnetic switch, physical thing. And so if you have solenoids and you're using them for something, typically they're associated with extruders. Each extruder has a solenoid. I think we made that more generic, so you can actually just do it by solenoid index instead now. Then there's some support for the trinamic steppers, utility stuff, like when you're doing your auto report or whatever from your trinamic stepper, all that stuff is in this. And then the rest of it you'll find in the TMC stepper library by Timu. Then we have TWI-bus, which is I2C. It's your own personal I2C bus if you want to make one and do stuff with it. So that's what this contains. And I've used it and it works. I used it and I had to use it for a project, and I refined it a lot during that process. And so it's actually very solid, and you can use it to make, for example, one copy of Marlin on one board talk to another copy of Marlin on another board and have them coordinate things. So think about that. You could do some things with that. Then we have, boop, the end of feature and the beginning of, let's see, well, I showed you LCD briefly, and that's got all the LCD code in it. Before I get deeply into that, I will take a quick look at the chat. We'll see where you're at. What's going on? What's going on, chat people? Welcome to the stream. Good to see you. Anything confusing, anyone? Getting the gist? I mean, this is all very obviously a very, very thin overview of what's going on at the highest level, which is the whole point. The idea, I think, is I think it's good to have a sense if you're teaching, to start at a very vague, kind of like give us a lay of the land from up high, looking down from the mountain, and get a sense of where things are at, and then little by little zero in on each area, maybe as part of a project, part of trying some things or giving examples. So in the future live streams, I'm going to be getting a little more closely in depth with mostly the module elements to begin with, so things like, and then also the G-code parser, which could be a module if it didn't have its own folder. But yeah, each of these things which is at the core higher level things, and then also the lower level things. So G-code parser, kind of higher level. just dealing with pulling apart strings and then sending data off to be processed by the other commands, by the low-level stuff. And then we'll look into low-level stuff like the planner, but we'll get into the details. And I'm going to just continue to try and take that approach where we start with an overview, and then we'll work down to the details so that you sort of know what to expect, and maybe we don't collide too hard with what's come up ahead. So any progress on pins debugging for the STM32 house? I believe there has been recently, and it continues to be. It's not my particular area. I'm kind of relying on a couple other people to get that stuff working. But I believe that it's close, and I know that we did have some updates recently about it. And maybe you're just throwing me a softball because you know that. But let's see. Any plans for a web-based config updater for 2.0? I hope so. I have worked on some JavaScript that the plan is to, well, there's a couple things that I'm doing to automate. One is to be able to parse the configs and pull in, basically this is the name config option, here's all its sub options, here's what their generic default values are, and here's the description, and then we have special tags inside of the configs that are like, these are the valid values of this option, and so we can pull those in too. And so what I want to do is pull that in and produce the ability to go from, and then also be able to pull that in for Marlin 1, 1.1, 1.2, and 2.0, or whatever, all versions. I guess 1.1 and 2 and 2.0, all the versions, 119, you name it. And basically then compare them and find a way of saying, oh, well, if this option is set to this in this version, then here's how it gets converted to that version. I guess you could say there's sort of a RESTful API kind of concept going on there. If I were to make it into XML, like maybe there'd be a way to automate it in a more simplified way. So I'm exploring that, but again, it's like most of my time is taken up right now with just clearing pull requests. So it's like, to get to that point is going to be after the freeze, where we're starting to do release candidates and we really determined what's definitely going to be in 2.0. And then the other part of that parsing I wanted to mention was that I'm also pulling it out for creating more documentation pages for the website. The downside being that when I go to generate documentation and work on it, it's going to be like so much slower because there's going to be 100, 200 more pages added. But the price you pay, I'll just have to get a faster machine or something. But yeah, for the time being, it's like there's one config page, but I want to make a page for every config, or at least every group of configs that go together, options, and so that there's a nice place that if you go searching on Google, it'll come up more easily, and you'll just have a top level link that isn't just a hash on the end of some other long link. And if you go searching on the website itself for some option name, it'll come up within the page search and be very easy to find. So that's stuff that I want to definitely do, but again, it's just the time is so much taken up with the pull requests right now. And but we have web expertise here in spades, so when we do jump into this, I'm not going to say it's going to go super quickly, but at least we'll know what we're doing, we'll know where we hit our limits, we'll know how long it's going to take, and we'll be able to give, we have fairly good confidence that we can do some of this stuff. And I did start a configurator which builds a form, but then, again, the problem with forms is they're not really any better than the config file, and sometimes they're worse. Because you have to kind of squint at it a lot more, where uncommenting an option and reading about it right there, it feels a little more in the flow. And forms, of course, also rearrange things and try to categorize them. So it's good in these things, I think, to have a wizard, a walkthrough that gets you through the generic options. And I think that also having our generic, or our defaults and our example configurations as starting points is going to help that process too, because you'll be able to say, I want to start from this one, and then I'll change some things. But yeah, it's hard because it's what do you hide, what do you show, how do you simplify it? It's a big challenge, especially UI wise. And if you've tried Marlin-conf at all by AKAJES Akajez, I don't know how to pronounce it, at GitHub. That is, I don't think that it necessarily improves things. I mean, it gives you the links from the option to the description, but it's like it just feels like a roundabout way where sifting through text is sometimes just it's not that bad. In the quest to try and find better things, I keep reappreciating how this simplified set of two files is actually not so bad, and even just using diff tools to bring your configs over sometimes isn't so bad. All the other alternatives just require so much extra work, and how much time can we save? I think what would be nice, and I think what a lot of people would like, is to have the website similar to Repetier host, where you configure it and then you download a hex file, and it's like just burn that. So maybe that's something we could look at, and maybe there's a way that I wouldn't say hosts, but there may be sometimes you want to like reburn different versions of the firmware from your host to do a different job for some reason. I wouldn't want to have to necessarily do that. It's definitely preferable to have configurable options instead. But I don't know. I'm spitballing here. Anyway, any other questions? Working backwards. Yeah, I was looking at the RTOS today, RTOS branch today. Yeah, the thing about the RTOS branch, and I keep mentioning, is it doesn't give us a whole lot over what we have. It's sort of, it just is, it's dividing up a couple tasks, but we already do that, and our way of doing it is definitely more optimized than the RTOS method. So yeah, if we want to really be thoroughgoing about it and build an RTOS version of Marlin, it would be I think it would be very different on a lot of levels than what we have. But I'm certainly open to seeing like if more and more processes can be broken down, and those processes are worthy of each having their own task, and it ends up amounting to like 10 or 15 or 20, and it really starts to make things sing, then yeah, I'd be into it. I'm just not seeing at this point any advantage, because it's doing only what we do, but in a more generic way, which is almost always has more overhead. But there may be some very 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 optimized RTOS that is like baby RTOS or mini RTOS, but it's kind of what we have. It's just a loop, and we run our loop, and then we check to see if things need to be done. And I wish Marlin 2 was as easy as 119 to program. Yeah, well, hopefully through this overview you'll get more insight into at least where things are. I think that it is easier to program. We haven't tried to like do anything too drastic, like turn everything into YML or create a bunch of APIs that are really complex and involve lots of namespaces. But we have tried to group code that goes together into classes, at least singleton classes, which are like namespaces, but let us play around with it. Let me use my dot notation that I like so much by creating a single instance. And yeah, there's there's some interesting things about the code. And let's see, anyone else? Crowley's implementation of power resume doesn't work if the file being printed is in a subdirectory. Yeah, I'm aware that there's a bug there. I haven't worked it out, but knowing that there's a trap is half of the secret to escaping it or something. I don't know. Anyway, let me click on my live button so that I'm seeing how far the lag is. It's looking pretty laggy today. Well, I'm on Ethernet, so I should be getting a good connection. I'm not going to touch the cable. All right, moving on. Let's take a look at what's in LCD, because this is kind of interesting. It's gotten a little more organized even more recently. First thing in LCD is a DOGM folder, which is for the graphical LCDs. And it contains all kinds of things which basically are there to support graphical LCDs, which I won't go into. But essentially your generic boot screen and status screen are there. There's font data there. There's all the routines for printing UTF-8 text. And there's a status screen handling. And yeah, all of that stuff there is there. And then there's this thing, Ultra LCD _ DOGM, is the Ultra LCD stuff that the graphical display does that the character display may not do. And then you have extensible UI, and this is a contribution from Aleph Objects, and Marcio there has been really diligently working on this and helping out a lot with giving us a way to have serial touch LCDs, touchscreens, and interface them in a way that is more generic. And this is mainly for Aleph Objects and their lulzbot and their really cool standing like control panel. And it works really well. I recently brought over, converted another LCD, was it Marlin LCD to this, and it took like no time at all. It was really fast. There's an example one in there, and yeah, I was going to actually rename this one Marlin to Ultra LCD _ Marlin, but I think there's another LCD that's being brought in, so there's going to be at least 2 examples of the extensible UI. But its basic aim is to create a consistent way of having new screens be able to do things that touchscreens typically do, which is they'll display your temperature and things like that, so they need that information somehow brought over to them. And so there's an interface that'll say, if temperature change, call extensible UI and let it know. And then extensible UI will be like, oh, well, I need to redisplay the temperature. So it handles all that kind of stuff. And you can imagine it can get pretty complex if you wanted to do, say, editing of the mesh on the LCD touchscreen. There need to be hooks in there for that. So as new features get added, it'll continue to get built out. And then those older displays can then, maybe if they get updates for their firmware, their touch firmware, then maybe you can, do things with that. I'd love to be able to get, speaking of this, I'd love to see some kind of reference platform for an open source touchscreen that is like, kind of the rap touchscreen, and that is programmable and kind of is the companion to Marlin and modern firmwares. And PanelDo is great, but I think we can, and it's cool because I think I can get at all the code for it. So that may be a good reference, and it might even be maybe one of the better choices. So that'll be, actually PanelDo is one of the things that's going to use extensible UI more, and I'm actually working on that. So among so many other things. Ultra LCD HD44780 Hitachi. This is your character displays. So all the character display stuff is in here. Has character LCD. See, there's a config. There's one of those conditionals. And here's an example where it's involved in bringing in the config pre, because it doesn't need too much stuff. It just needs the conditionals that were set for the LCD and a few other things. So yeah, pretty neat. So this basically just is, is going to have the handling for things like your custom characters that character LCDs can do, and that kind of stuff. Language is where all the different languages are. So English is the fallback language. Everything else, if it isn't defined some message, you can see here, will get a default in English. So if you look at Spanish, ES, and these codes are all an ISO country code that we've decided just adopt the standard ISO country code so that it's consistent. We don't have to make any guesses. Sometimes it's hard to guess. Is Vietnam VN or VI? It turns out it's VI. So yeah, so here's a language that's defining the message, and you see it doesn't have if and defs around everything. You just define the things. It has this UXGT thing around it, and that's there so that there's a script that looks at these and figures out which characters you've used, and then builds the font data so that you have only the minimal font data you need. But yeah, all these things are defined here, so that all the strings that you would use, and this is only strings that are displayed on the LCD. Anything that goes out to the serial port must be in English. It's supposed to be in English, and that's so that the host can look for it and then respond to it. So anything that the host might want to respond to, generic messages you could probably get away with not having, it's just going to display it to a thing, but hosts do expect certain strings, and that's actually in a file called language.h, which is separate from this. It's actually, was it in the language.h.folder? Let me see. Yeah, no, so these are the individual languages, but there is actually a language.h that and that has all the strings that go out to out to the serial port in English. So yeah, a lot of different interesting ones, and let's see, just to keep it interesting, here's some Cyrillic, so you can see it's just, in Marlin 1, you had to have a file that was written for character LCD that had no UTF-8 in it, and you had to have one that was UTF for the graphical display if you wanted, and we didn't optimize the fonts. So now with Marlin 2, we have different languages optimized, and everything works so much better. Nederlands, here we have the kana, Japanese. Yep, so you only just type one UTF file, you run the script, and you're done. Although you don't have to run the script because, at least in the releases, we're going to have it all done for you, and it's included. So it builds something that goes back into Marlin, so it's kind of handy. All the menus have been moved into a menu folder and then given their own individual files. So this is maybe one of the reasons why you were finding it a little hard to program Marlin 2, is because things have been moved around into their own files a lot. But this gives us a high-level overview of all the menus and allows us to more easily partition what's being included. So here's a menu for motion, and this is almost always enabled, pretty much. If there's a menu, it's there. As you can see, it has LCD menu. And this handles manual moves. You've got menu main. You've got all the menus. So just quickly going through them, there's a generic menu code, which is for menus. We actually have a game folder, which has a few games in it. We have menu advanced, which is your advanced settings, backlash for your backlash compensation. Bed corner leveling is its own file, bed leveling, its own menu. Configuration, your generic configuration stuff is there, right to your EEPROM. Custom menu, if you set certain options, custom user menus is the name of it. Then you'll get custom menus that have your own items added to them, which are basically G codes that you can run with a title attached. Delta calibration, G33, right here. It actually has its own menu and is really handy for calibrating your delta. Don't build Marlin without it for your delta. Menu filament, filament change, yeah, that's all here. Then there's a game menu. There's, I was just indulging. I was very bored with programming firmware. I thought it would be fun to see what the LCD could do. Made a few games, so apparently certain games you can do. Info, that's just, your printer info, and that's handy. If you're a vendor, you should include this so that people can see what board you're using and stuff. And here I see I've commented out a bunch of things, so those could probably get pulled out. But this used to depend on more, and I think that I commented those out when I was refactoring. So now we know they're not really needed. At least it passed the tests. So. Then there's your print job recovery, which is power loss recovery. And that's got its own items, basically resume, stop, etc. And then LED, so you can set your LEDs, brightness and stuff, colors. Your main menu, of course, you're familiar with that. Mixer, one for the mixer, just adapted from G-Tech, thank you. MMU2, which again, Prussia's MMU2, we got a menu for that. Motion, which is for your move axis. SD card, you know what that is. It actually has the SD card listings in it and stuff like that. You've got a service menu, so when your print counter tells you it's time to do certain services, it'll put up warnings, and then you can set when you want certain services to be done, like every 3 weeks or whatever, or every 50 hours of printing or something. Menu temperature, yeah, so all your temperature stuff, your fans. Trinamic, TMC. Tune, menu tune for all your tuning options. This is a little different from 1.1. Some options have been moved around. So, and then there's a UBL for universal bed leveling, which is separate from the menu bed leveling because it has extra cool options. So that's the menu folder. The rest of the stuff in here, I think the only thing of interest is Marlin as an example of the extensible UI is a really good file to check out. I highly recommend you do. And then thermistor names, This just contains the names of all the thermistors that we've defined. And I guess we need to make one more 1000, which is going to be like user, I think. Recently added user custom. We'll say custom. There. And then the Ultra LCD code itself, which is all the generic stuff, basically the core LCD code, which is more about, as time goes on, it's much more about the integrated LCDs that are connected directly to your ramps board or your board than it is about boards, than it is about touchscreens. Some touchscreen stuff does overlap here, but for the most part, this is almost always about the integrated screens and dealing with those. And your encoder and your wheel and the button. And there's some other things. The scrolling messages are handled here. Your kill screen making a little clicky sound when you press the button and all that kind of stuff. So yeah, that's what, but you can think of Ultra LCD as being, especially .h, as being like the core LCD thing right now for all sorts of LCDs. When you include it, it generates, whether you're using extensible UI or a built-in directly connected SPI LCD, it will do the right thing and bring in the things that need to be brought in, and it defines a class called Marlin UI, class Marlin UI. And Marlin UI is the class now that is the, and I think I define it as Marlin UI extern. I just give it the name UI, so it's just UI dot anything throughout the code is this Marlin UI class, and all the things like setting your status message and stuff are done through this, and then it passes it on if need be to the extensible UI, and so there's a single interface, and it gets where it needs to go. So this is fairly, again, we're building from legacy code, and so little by little, some of these things will probably migrate around, but for now, it's working fairly well, and the organization is improving a lot. So back to LCD print, again, generic things like where to put the cursor and printing strings. So yeah, all of that stuff is in LCD. I guess that pretty much leaves us with G-code. And G-code is got a lot of subfolders in it, but this is where all the G-codes have moved and where the G-code G-code class and G-code handlers are G-coding. But yeah, we have, I've actually separated into classes. The queue, which is the blob of, or basically the list of commands that have come in. The parser, which knows how to parse a single command. And the G-code handlers, which are gcode.cpp. So the actual functions or methods that, like G-code colon G29, for example, or whatever, are all defined in gcode.h. gcode.h, where this whole list that you see here used to all be in Marlin main.h or .cpp or whatever, is now in gcode.h. And so all the G-codes are briefly described, and then based on which features are enabled, I'll scroll down. Sorry for the fast blurry scrolling in my face. But here you see with each feature that as each feature is enabled, that you get certain G-codes or not. And so if you don't have this feature, CNC workspace planes enabled, you will not get G17, 18, 19, and it'll complain that it doesn't know what you're talking about. So that's handy to know. The host at this time does not will not disconnect from you, because I don't think we now say error, but it might. So I have to check that, but I think we don't say error. The word error is a flag, a red flag for right now for the default setting of Octoprint. I think it'll disconnect automatically on error. So if you turn that off, you're good, definitely. But if you're not using certain G-codes, like setting inches or setting millimeters or whatever, I think the generic behavior is to say, or the default behavior is just to throw back, I don't know. And that's just a handy thing, but we wanted to make it not be an error. So I believe we did work that out. I hope so, because I'm claiming we did. So then, yeah, SD support. So this file is really actually a really handy way to see which like codes go with which feature, and you can very quickly get a nice overview. Gradient mix M166. Yes. Then you have all the G codes are now separated by category. And I tried. This was a long couple of weeks of really bad sleep, and I messed up my shoulders and just hunched over typing all that time, as you can imagine. It was really bad for my shoulders, but it needed to be done. It needed to be done, and so I did it. And amazing. It took a while to finally work, but my first approach, little history on that, is just I took all the G codes, which were in one big file, and I separated them out, but then I made one big file that was like including them all, and so they were all just actually .h files. So by default, .h files in your C compiler or C++ compiler are not compiled. They're only compiled when they're included by something else, either an H file that's been included by a CPP file, but everything is rooted in a CPP file. For each CPP file or C file that's getting compiled by the compiler, it's starting afresh. It has no idea what's what, and it redefines everything, although it will cache things if you're doing a big job. But with each CPP file, it only includes the code that it knows. And so I wanted to first have it just basically be exactly what it was in 119, but still be organized into separate files. And then little by little, I brought it over and made it more class, finally made it into a class. And it wasn't really that hard. It was just a lot of meticulous work, and then also deciding within each one. So let's pick one. M111, well, it doesn't need much. Maybe pick one that needs some feature here. Okay, so yeah, so let's pick M80, which is your enable power. So if we look at M80, we see it's including certain things based on options, and so and has power switches, the big overriding one, and then M81 is always available. So just sort of working that out and having each file do that, and then make each one its own little unit that's readable was, I think it makes the code better, because, well, here's one of the things is if you're using your editor and you just have something like this where you bring up a text box and can type the name of a file, like I just want to edit G29 or something, I can bring this up and I see there's 3 G29s, and there's also UBL G29, and so they're all here right at my fingertips. I can just bring it up. Whereas before I would have to do something like find, maybe : G29, and it would find it, and then I'd pick the one I want, which is this, MBL, okay, and then bring it up that way. So it's better for coding to be able to just type it in and just bring it right up. Oh, what do you need? M42? No problem. I got it right here. Instant. So if you look at each of these, they're just, and I won't go, clearly I'm not going to go over every single G code, but I'll just show you what's in each folder and give you a sense of what's in each folder. So bed level, G codes for bed leveling, G29, essentially. M420, G42 for checking your probe repeatability is considered part of bed leveling. And G26, which checks your mesh, is there. And then calibrate. Calibrate is for commands for calibrating. So G28 is homing. That's kind of calibrating. It's figuring out where your home position is and calibrating the edges. G33 for your delta. Maybe that would belong in a delta folder, but this is where it is. G34 and M422 are grouped into one file, but could be split into two. But they just go well together because they both rely on the same condition, and the same includes, I think, for the most part. So as I scroll through this, there is G34. And then M422, in case you're curious, is automatic alignment parameter selection. So look it up. G425, I'm not sure, calibration G code. Yeah, so that's for your backlash. Compensation, M100, check your stack, M12, closed loop. So yeah, a lot of these you may not know at all. Backlash goes with G425. M48, Z probe repeatability. Oh, did I think that was bed level? Oh, G42 is move to mesh coordinates. Sorry, I had that wrong. The repeatability test is M48, and that's considered calibration. Makes sense. 665, this is all for Delta and SCARA and things like that. 852 for your skew. Yeah, calibration. Config, these are like, changing your config options that aren't necessarily like motion or, well, they can be part of motion. 220, for example, sets your feed rate percentage. And so things like that, where you're setting config values of the kind that you would find, that change behavior, sort of like on the fly. M92 sets your, for example, sets your steps per millimeter or steps per unit. If you're in inches mode, it's assuming you mean this many steps per inch. So consider that if you happen to use inches ever. I've been told there's a special place in hell for people who use inches for CNC or 3D printing. There may be some reason for choosing inches. Yeah, control. Again, similar to config, but these are like setting things like turning a device on or off. A laser or a spindle, for example, turning it on and off. So I won't go over all these commands, but you can look through this. And tool change is also included here, interestingly. Recovering from a hard stop, M9099. M108, M112, and M410 are grouped. But those are part of, like, they're also with the emergency parser, so that's probably why. Again, there was a reason why I grouped them together. There was a bug in an old Arduino where it couldn't build because of a very, very, very long command line. So we started combining files together to make it shorter. And now the bug's gone, so it's like, why? EEPROM, all the EEPROM commands are in a single file. So your M500 through your M504, but they all call through to a class called settings, or at least an object called settings. Feature, so yeah, if you get into this, similar to this mirrors the feature folder, and there's the G codes that go with the features. So if you look at linear advance, actually it doesn't have any, oh there it is, M900 goes with linear advance. So this breaks it down even more. A camera, M240, M355, like, you can see that I could have left these all top level, but you'd be like, what does this go with? So they go with the certain features, and so each one, MMU2 actually has its own code, M403 set filament type. So yeah, all kinds of commands are here that you might not know about. Check them out. Geometry, how big is your printer? What is the, steps per, set the current position, set the coordinate system, set the home offsets, change your workspace planes, so geometry. Host, M110, set the current line number. M113, is, what is it? Keep alive, yeah. So how host keep alive? It's send a message to the host if you're busy, so it knows that you're still there. Stuff like that. M115, again, capabilities report. Display a message to the host console with one M118. Output end stop states and host prompt support. So yeah, all this stuff is here. LCD things, printing a message on the LCD, playing a beep, doing a pause with a message. Motion, so all your G0, 1, 2, 3, 4, 5 are all there, plus G80, which is your motion modes, and your M290 for baby stepping. Yes, you can actually now baby step directly with a G code. Probe. Doing an individual probe, dealing with the sled if you have a sled, doing a probe sideways with a G38, or probe away. M401 is deploy and activate or deactivate. M402. M851, your probe Z offset, and M951 for the magnetic parking extruder, which you probably never heard of, but it actually gets its own code because it has settings, basically, and so this is for setting all the various settings. And there's that. SCARA, if you have a SCARA, there are commands for calibrating that. SD card, all the SD card stuff is here. Stats for statistics, so your things like your current print time or the last print time, and start print timer and pause print timer. So this could really all just be print timer. I could call it print timer. Temperature, setting in your temperatures and your fans, and even auto reporting your temperatures is here, and calibrating your nozzle, all that stuff right here. Units, are you in inches, or what are you doing? Using temperature like Kelvin, you might as well turn on Kelvin. You can actually print Kelvin. You've probably never seen somebody have it on their display like Kelvin, but yes, you can actually do that if you really feel like it. Set E codes, so yeah, M82, M83, and that's it. That's all the G codes are right here in this folder, like easy to find. And then it's part of what I hope will make like the documentation easier as well. I'm not going to pull out like all the parameters, but I could do stuff like search for parser.scene, which looks for a certain letter, and find out what all the commands are pulling, what they're looking for, and see if there is a way to like confirm that the documentation is complete or something. I don't know. So anyhow, parser, yeah, so this contains your parser, and again, the G-code CPP, which is your generic stuff, plus support functions that go with, like, to help things like some certain motion commands. And then, yeah, one of the things I did was I created this thing called process parsed command and parser parse. I separated things out a lot. So you could actually say, give me a string, parse it, which means, now it's ready to run that G-code command, and then process that parsed command now, and it'll actually run it like a function. And so we actually have the ability to use G-code just like a function, because when it comes back, it restores all the parameters that might have been there from the G-code you're currently calling it from. And so you can carry on just as if nothing happened. It's really cool, and like I highly recommend if you have some feature that you need to implement, and you can do it like by using existing G codes and calling them like functions, go for it. And there may be some reason why we might in future want to take parts of Marlin and treat them like that, create internal G codes that only Marlin knows, and then call them like functions so that they do G code like things. And that sometimes can be more optimal, but you do have to make the G code string, and so it's a little silly sometimes to do things that way. So that's the overview of the SRC folder: core, feature, G code, HAL, ink, LCD, libs, module, pins, and SD. We've looked at them all. Can you believe it? Now you know everything about Marlin, at least from a high level, where things are, all that stuff. Should I take a look at one more thing? Let's take a quick look in the build root. See what's here. The most interesting folder in here is not bin. Bin is used for when we're doing Travis testing, which is like the automated testing. So it just needs to be there. You can actually use it on your own machine if you're a developer, or if you just feel like playing around. You can actually call these functions and like opt enable, for example, and have it like enable an option inside your config file, and it'll actually just enable it from the command line. And so you can actually have if you know what your config changes are, you can actually create a little script that just has opt enable, opt set, opt disable, blah, 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 one after another, and you can just run that script. And then when you want to take your, upgrade to the next version, you just get the default config, download it, run your little script, and it does all the changes. So you could conceivably use these bin scripts like opt enable. You can see it's not that complex. It just calls sed or gsed and replaces some text. All these little functions, these little scripts, can be used to as a substitute in a sense, or a way of migrating. So something to consider, but we use them pretty much primarily for build tests. And then we have an Etsy folder, which we don't use for anything. I'm not sure why it's there. At least I don't, but it's there for a few reasons. A-style RC is a legacy piece of cruft left over from a time when we thought we might have automatic formatting, but it just doesn't work. Automatic formatting is not, it's not smart enough yet. Share. So this is the stuff that is sort of meant for users and and vendors and others to take advantage of. So we have a folder called Atom. So if you're using Atom, there's an auto build now. You can build Marlin just by saying auto build, and it'll look at the motherboard and say, oh, well, I know which platform to build with, and it'll just go from there. CMake. So if you're using CMake rather than make to use to run the like the make file or do a build from the command line, you can have the option to use CMake. Fonts. We include a few fonts. The 6x12-3 is all the font stuff combined, but it's there as a data source for our gen all font script, which goes through and actually figures out which characters you need, and then pulls them out of the BDF font, and then produces a file that is suitable for Marlin. So all this is handled here in fonts, and there's some scripts, and there's actually a README MD, which you can look at. It looks a lot better online. That actually gives a fairly good description of how to, and I've updated it recently, so you can get a sense of how to do fonts. And actually the better place would be marlinfw.org/something. But go to the menu and you'll see that there is actually a section on fonts and how to update them. And I could give you visual aids and open it up for you. marlinfw.org. There I am making excuses. Let's see. Oh, here we go. Documentation, development, adding new fonts, and then language systems. So these are fairly well updated at this point. Actions, translations, mappers, mapper notes. So some of this stuff is really way too detailed, but it's really handy if you're into this stuff to understand how it works. I'm just going to quickly look at adding new fonts because I think this is the part I updated a bit. Term 1 CD, yeah. So let me know if this is all correct. If you happen to follow his instructions, I know what I'm doing when I use it. So let's quickly finish up the fonts folder. Anything else worth looking at? Gen pages. Yeah, all this stuff goes together, and these scripts all work together to build the font data. So Git. These are the Git scripts which I've described in a previous live stream that I use as shortcuts for doing my Git migration and stuff. Don't remember if I gave an example of everything, but essentially, yeah, when I want to create a new copy of Bugfix 2.0, mfnew2, very simple, boom, I have it, I'm done. I don't have to use anything else. Desktop. Pixmaps, this is just stuff, so if you want to make your Marlin hat, well, you can get an SVG file and or a PNG file and do some, use it for your sticker or whatever. So we've used these for our Marlin inside stickers, and working on a Marlin t-shirt design, so that's going to use some of this SVG. Then we have Platform I/O, so this is support for your Platform I/O, and you probably don't have to look at this much. These are basically the scripts and things that are there to support the platform.io.ini file when it mentions, oh, I need to run this Python script as part of the build. Those will be there. We have a thing for creating a speed lookup table, which is important for AVR, but not for other platforms. Then there's a temperature lookup, so we have that. If you want to have a new thermistor and you know what the parameters are, you can actually use that script. There's a find missing translations, which needs some updates, but that looks for strings that haven't been defined in the other languages yet. And so it gives us a list, actually. And it needs a little work, but because it doesn't notice if something's still in English in the other language. But I'd like to be able to, it just looks that the string is missing. And then there's a SCAD file, which if you get the output from your bed leveling, and you can get it in this format and then paste it here, and then when you open this up in OpenSCAD, it shows your mesh. It's similar to the plugin for Octoprint that shows you your mesh. I think it's called Live Mesh. if you have live mesh, use that. It's better. But this is a good way of just like if you're not sure what your mesh looks like, or you want to like look at it and get a sense of which points are weird, and you don't have a graphical display that can, or a touch display that does that automatically or something fancy. This is good. I wrote it over a weekend and tried to make it so it was like obvious from looking at whether a point is below or above how much, and make the labels like line up and stuff. And I could, I'll quickly demonstrate it since we're doing a video, we're demonstrating things, but sure enough, let's open that up. Here we go. And so, yeah, this is the mesh that I was using as my example, and you can see it's really meh. But if you animate the design, view, animate, where's animate? Animate. I have it like, oh, I have to change the time. Sorry. We'll say 20, 20, 20. I don't know. Oh, there we go. And so it just sort of expands the points up and down. So you can see that, oops, there we go. So yeah, I can see the points in proportion. Like, yeah, the ones that really stick out are the ones at the edges. And, if they had a slider in this interface instead of a time animator, I would use that. But that's what they give you. So there's OpenSCAD. So you can view your mesh. You have to enable something called, I think it's SCAD mesh output or something. Yeah, there it is, SCAD mesh output. So you just enable that option, and then you can copy it more easily in that format from your console into that script and open it in OpenSCAD. Then we have Sublime. So there's just a Sublime project file. And then there's a RepRap syntax, which is a little better than the one that comes from their version. There's like some old version. And then there's a Sublime menu that adds some things, auto build basically. And I don't know how good it is. I haven't played with it in a while. But there is a README. So how to do it, install deviot, yeah. So, and it may be optional because you just need to have Platform.io installed really. Deviot is, in case you're wondering, is just Sublime's version of Platform.io, and it's sort of a thin pass-through. It isn't super complex. And then, so that's an attempt at making an auto build for Sublime. And it may or may not work. I haven't checked it lately. But that's there. Then we have tests. That's just for when we go to upload changes. GitHub or Travis CI looks for that and runs these tests. That's how we catch a lot of bugs, is by uploading them, and then we see, oops, red X. Finally, there's Visual Studio Code support and basically auto build. You don't need to look closely at this, but basically this is a folder you bring into Visual Studio Code, and it gives you the auto build option. And last I checked, it wasn't working, but I've done some changes lately, so maybe it still does now. But yeah, so that's, I can't go much further. That's the full overview of pretty much everything in here. The Platform AOI file is a whole subject unto itself, so I won't get too much into that. But essentially, it just defines the platforms that we currently support. And so you can always look into this and look at all these ENV lines to see, oh, what do you got now? You got Do? Great. You got LPC, 1769, Melzi, Rambo, Sanguino, you name it. Yes, we've got it. I was actually going to make a big list of these at the top of the file, so it'd be easier, but for now, this is where you find them. We even have a special F613 because it has quirks. And the thing is, each of these environments, it could come down to one small difference between one and the other. Hopefully we'll have a way we can say, hey, by the way, inherit this environment, but take away that or change that. I would have to play around with and see whether that's easier. But for now, it's not that much of a hassle. As you can see, the file is not, there it is. It's not that huge. It's just this many lines. So, yeah. Marlin, here it is. I want to thank you all for joining me. I'm going to take one last round of questions before I run. Then I'll do that whole thing where I say like, share, subscribe, beg, all that stuff. So where are we here? We're down to, let's see, here's a good question. Techie Dad asks, would the change from early M2.0 define zmin probe end stop to define zmin probe pin 32, what would be a suggested way for a manufacturer using RAMP's custom board to define a Z stop and Z probe? Well, actually, right now we have a single option, which is in Marlin 2.0. It's been updated so that it's now you define whether you're going to use the Zmin end stop or not. That's it. And there used to be two options where you'd say I'm either going to use it or I'm going to use a custom pin. So it's now down to, let me see if I can remember the name and find it. So I'm confirming, I want to be authoritative about this. Zmin probe uses, is it uses something about that? Yeah, Zmin probe uses Zmin end stop pin is the only option now. If you don't set this, it assumes you're using the other one. And then if you're using the other one, you define it. And now you can, and we put the override basically here. So it's like, having the other option in a way, but it's not meant to be a one-to-one replacement so much as, well, now that we've changed it, we might as well put the default here and keep it here. So if you don't define this, you'll still get a Zmin probe pin from your ramps file if you haven't defined it, and if you've defined a probe type. So if you say fixed probe and you still don't define this, you'll get the default one. So I hope that clears up what that's about a little bit. And then as far as end stop goes, like if you want to have a separate end stop, you do have to undefine this, and that's it. Your pin will be set either by the default or by this, as long as you set a probe. Okay. And he mentions that he asks, as the board that he has is using a probe for leveling only, and the end stop is for homing. That's fine. Yeah, that's basically don't use the Zmin end stop pin, or it will be used for both. Essentially. So just disable this. Next. Thanks for everything. You're welcome, Jake. Info Mario wants to know how to change the menu tree, the position of every menu. Well, you just go in and rearrange them. Just copy paste. If you get an error, it says you can't find something, figure out the include you need to make it find it. So for example, if I want to move something in the main menu, I'll go to menu main. Here's the file. I open it up. I find some item I don't like. Let's go down to the menu main itself. Here it is. And we look in here, we find, temperature menu. I would rather have that at the top. I'm going to move it up here, and I'll just put it up here right after back. Done. Now, if I wanted to move it to some other menu, it may take more work. So, it depends on what dependencies it may have. And if it's something like mixing extruder, you want to take all these lines with it and move them along. So I'm going to put this after. So that's the most straightforward, simple way to do it. There is no, somewhere else the tree is defined as a structure and then we rearrange things based on the structure. That would actually waste a lot of resources and not, unfortunately, we're, still in the paradigm of having to save resources so we can fit on a 64K board, which, it's part of our code here, Marlin, is to keep it working on the small boards. So we do sometimes have to make things a little trickier or a little uglier or a lot uglier, as you can see with something like this, if, to make it work. But, that's where we're at. And as far as moving things from one place to another by copy and paste, it's, there's nothing too complicated here. It's fairly straightforward what's going on because everything's labeled menu item. So at least we have that. As for making more complex menus and stuff, that's a big other subject. I would look at the video I did on the mixing feature and porting it over, and zip through that, maybe run it at 2x or something until you find the part, or look at the last chapter where I summarize everything, and that shows a little more in depth of how to make new menus and how to like do custom display and other things like that, which are a little more fancy. Yeah, and if no one has any more questions, then that easy. Yeah, I know it's surprising, but yeah, it's I mean C++ is it's a high level language, so as long as you're not doing anything too crazy, you can shift things around fairly well. The thing that came before may not necessarily depend on the thing that came after, or vice versa. So you can play around with it and not worry about things exploding too badly. And if they do, you almost always get a really good error message or warning, and not just something catching on fire. So yeah, if that's everything, I'm just going to thank everyone for coming. I want to go and get a snack and a glass of water. But I'm going to be doing another live stream on Sunday. This time I'm going to be talking about, again, 8-bit stuff, looking at Atari. I might talk a little bit about this old game that I made back in 1990, which I got a copy of off of eBay for an embarrassing amount of money. But I really wanted to have a physical copy because I actually haven't had one. The source code is long gone since I abandoned my Amiga in an apartment like many years ago in Boston. So I hope I'll be able to show you that a little bit. And then the next stream on the subject of Marlin is going to be again next Thursday, hopefully earlier. It'll depend on my sleep schedule and where I'm at that point. So I hope you'll tune in. If you enjoyed the information presented here and you found it helpful and informative and enlightening, I hope you will like, share, and subscribe. You'll find links in the description. The emphasis is on share because this information, I really want to make sure it gets out to lots of RepRap users and have people understand as much as possible, like what's going into Marlin and how it's organized. And as this goes on, I think it'll be really informative for young makers and coders, people who are into engineering, to sort of see some of the ins and outs of how these very large, complex sketches are built, and get a nice idea of the interesting features that these embedded chips have and these embedded boards have, because they're really very powerful for all that the simplicity at a certain level that they do, just turning switches on and off. They can do some pretty amazing things. So I'm really looking forward to talking about the more interesting details. So please do share as much as possible. I want to get this out to lots of RepRap users and young people and get people inspired about this stuff, because it can be very dry and uninteresting, and not seeing the and especially when you look at it from a high level and you see just all these ants marching up and down the screen and like what the hell is going on? It can be so overwhelming. So I definitely want to make sure that as I'm presenting this, I'm doing a fairly good job of speaking in English and making things accessible. So I want to get some feedback on that. So please, yeah, again, like, share, subscribe, smash that like button, and I will see you next time. Thanks, everybody.